Hello, thank you for joining yet another Embedded Academy What's New. So it's the second time within 3 weeks, but we've been publishing quite a lot of new content lately. So I would like to share it and don't have like a 1-hour meeting. It's better to have several events with just 20-25 minutes. For today, I have different topics I want to show you. First, we start with newsletter and survey, and then we look into the new content which has been recently published. What's brand new since last week? We started via LinkedIn with a newsletter. And we're very, very grateful that we got more than 500 subscribers within a week. So I'm really happy about this, meaning that in the long run, we will replace the news page of the Embedded Academy webpage by this newsletter. The newsletter is published openly, so you can access it also if you are not signed in at LinkedIn, so you don't have to be a LinkedIn member for it. We will provide the link in the chat. So from the last Embedded Academy What's New event, we made a short summary, put in the links and explained a little bit of the background. And this was the first newsletter. Second newsletter will come soon. The idea of the publishing rhythm in the long run should be once per month, but I think for the next weeks we might publish every other week because we have so many news to share. Yeah, so this is for now. This is the Embedded Academy news, and we're happy to, maybe pass the 1,000 subscribers within a month would be nice. And another thing I would like to discuss is we started a survey. You know that on the Embedded Academy webpage, we have this I did not open. We have these learning journeys based on job profiles. Now I'm starting the video. We have these different job profiles defined here, the different job profile you might have and what's the right approach to learn. We go to the function develop. So there's one page for each job profile. So you have a picture again of a job profile, a short explanation on the person or the job itself. And then you have a courses within this e-learning package shortly explained that the learning journey is going step by step. So the one you should start with is first, and then step by step the next and the next and the next. So for example, for an automotive software quality engineer, we say, okay, you need a certain embedded software know-how and you need automotive SPICE as a know-how, and you should have an understanding on automotive cybersecurity. So this is like one of the recommendations, and these different job profiles, we are asking you in the survey to give us a feedback on which job profile applies to you and maybe which job profile is still missing. And you will also see in the chat the survey. Just to have a short look at the survey, it's not a lot. It's just a few questions. First thing is just some around data which we need to be able to do a good evaluation of the feedback, to know where you're located, which industry you're in, and then we are already at the job profile. You choose the one which fits best. give us an indication what else we should cover. Then additional technical fields we should cover. You would like to explore additional topics. If you want to have a result via email address, we will also give you a discount voucher for the Embedded Academy access when we send the email. And if you want to tell us anything else, you also have a field. So you see, it's done within quite a short time, and we would be grateful about your feedback. So, and of course, we'll publish the news, and we will work on providing what is needed by the community. So this is what I wanted to show you there. And now we go to the Embedded Academy releases themselves. We have here the starting page, and you see here the new courses which were published online. In the last event, we already had a look into the encryption methods, and today we'll have a look at mathematics in encryption. So for the encryption methods, you need some mathematical background, and parts of it, and the other part which is not provided, I will also explain, is part of this mathematics in encryption. And we are continue to work on the e-mobility topics as well. And there it's the electric vehicle system, so the system view on the electrified powertrain within the vehicle, which is the new course which we are providing here. Okay, let's have a look first on the portfolio again, because I want to have a look at this topic of encryption. We introduced in the last event, which was around 3 weeks ago, Introduction to Cryptography, which is a general introduction into the topic. What is cryptography? What are the roles which are referred to often, like Alice and Bob and some others, like Eve for eavesdropping, and the concepts of symmetric, asymmetric, and hybrid encryption are explained. And in this event also we introduced encryption methods. There are dedicated methods which we discuss in detail on symmetric and asymmetric encryption. And to understand these methods, we now also provide mathematics in encryption, which are supporting to understand some of the methods, how to encrypt and decrypt data. So what's the content of mathematics in encryption? We will have a look at substitution and permutation, function and inverse function, XOR, modulo calculation, and multiplicative group of integers. It's also modulo, belonging to modulo. So these are some typical things you need for encryption. There are other mathematical background, especially matrix calculation, which you need as well. But this is like a bigger mathematical chunk, which I would say you need to train otherwise, and it's usually part of an engineering education. Whereas these topics might not be the typical topics you have also in control algorithms and so on, which you are learning. So let's have a look at these different parts. These different functions we structured into 3 e-learning lessons: substitution and permutation, function and inverse function, XOR and modulo, which also includes the multiplicative group of integers. So I would say we have substitution and permutation is I would say, quite simple and easy to understand, but nevertheless, you should know about it.
The term substitution comes from mathematics and describes the replacement of one term by another. Usually this should simplify the original term. Let's first take an example from mathematics. For this we use the arithmetic term x squared plus 2 is equal to 27. If x squared is substituted by another variable, the term is simplified. Substitution can also be used in cryptography, for example. In the so-called Caesar cipher, all letters of the original alphabet are substituted by the letters of the ciphertext alphabet. The letters of the ciphertext alphabet are obtained by shifting the original letters by a predetermined number of positions in the alphabet. For example, one can shift the letters by 3 positions. The original letter, A, is then always replaced by the letter D, and the letter K by the letter N.
Okay, this was substitution, and the next one is permutation.
The term permutation comes from a Latin word. Translated, it means interchange. It is usually used in mathematics, more precisely combinatorics. Permutation means the rearrangement of objects in a certain order. For instance, if we look at the numbers 1 to 4, you can rearrange the complete order. But it is also possible to switch only the 2 and 3.
And this substitution and permutation is applied in encryption. And you see here, there's also other parts coming without repetition and with repetition. And it's getting more complex if you repeat and rearrange more than once. Yeah. Then combined with some other mathematical measures, then it's really getting difficult to decrypt. So this was the first aspect I wanted to show you. Then we have function and inverse function, which is also very important. I will just click on it first.
In this lesson, the mathematical background of function and inverse
function and inverse function.
Function between two sets A and B maps every element in a function between two.
No. With a function and inverse function, if you encrypt something, you want to also be able to decrypt it, meaning that having the possibility to inverse the calculation must be given. And this is not the case for each function. There are only specific functions which can also be inversed. So this is a very important aspect. And of course, this explanation here on a mathematical level, it's done now easy to understand. Yeah? So I want to start.
Function between two sets A and B maps every element in A to an element in B. The idea of sending the elements in A to B is also illustrated by its mathematical notation. We also tend to say that f of A is B, or f applied to A gives B, and use the notation in the second box. Let's look at a basic example. We say that the set A should be the numbers from 1 to 3, and the set B should be the numbers from 5 to 7. Consequently, f now maps from the set 1, 2, 3 to the set 5, 6, 7. Moreover, we assume that f maps 1 to 5, 2 to 6, and 3 to 7. Hence, every element in A is mapped to an element in B, as the definition says. Alternatively, we could also say that f of 1 is 5.
So then we have invertible function.
Next, we want to examine our function closer. We want to check if for every element in the set B there exists exactly one element in A, which are mapped to each other. If this is the case, we call a function invertible. For example, we say that the set A contains the numbers from 1 to 4. The set B should be the numbers from 5 to 8. Now, we assume that our function f maps 1 to 6, 2 to 7, 3 to 5, and 4 to 8. We see that for every element in B, there is exactly one element in A such that f of A is B. Therefore, our function is invertible.
So, and if a function is invertible, you can have then the inverse function and get back to the original state. So this is what I wanted to show. And then for the last part, XOR and modulo, we'll just look at the starting explanation on modulo, which is, I would say, easy to understand and nicely done.
Consider the residue class ring ZMZ. This means we consider the residue class ring ZMZ.
So now I'm a little bit lost. We'll go to XOR.
The term XOR stands for the expression exclusive OR. Another meaning for this would be either or. You might have also already heard of the XOR gate in some context. By an XOR operation, we usually think of the addition of bits modulo 2. In practice, this works as follows. You usually do an XOR operation for each individual number of the bits. At first, we add the respective numbers of the bits using common addition. Next, the individual results are considered as single numbers. The numbers are converted back to zeros and ones. To do this, you check whether the individual numbers are even or odd. Is the number even, then a 0 can be noted. If the number is odd, then a 1 can be noted. We will illustrate this with an example. First of all, we add the individual numbers of the bits up in the way we are used to. So all ones in a column are added. From the result, the individual numbers are now considered. And then we check whether the number is even or odd, resulting in a 0 or a 1. Also note that the usual symbol for this operation is a plus in a circle, meaning the calculation should be actually written down as shown. If you want to look at a more mathematical explanation, click on the button on the right.
Okay, then we go to modulo.
The modulo calculation is a mathematical operation which uses division with remainder. Though this may sound difficult, we already use it in our everyday life when talking about the time. Instead of talking about 14 a.m., we say 2 p.m., and instead of 18 a.m., we talk about 6 p.m. What we are doing here is subtracting 12 from any time past noon, meaning we subtract a full clock rotation of 12 hours. And this is already a calculation modulo 12, since we said that 14 is the same as 2 up to a multiple of 12. So, modulo 12 means that both terms are equal up to a multiple of 12. Mathematically speaking, we say that 14 equals 2 modulo 12. To better separate this from a common equality, we use an equal sign with 3 lines. Of course, we could have more than one clock rotation, or even a backwards rotation. Hence, all of those numbers are equal modulo 12. In general, you can of course do this for arbitrary values other than 12. If you want, you could simply think of a clock with more or less than 12 hours.
Okay, this is like a view into the different parts of mathematics for cryptography. Then more or less we are, for now, we are done working on these topics. We might resume and update and enhance later, but currently cryptography is now complete. The next topic I want to show you is electric vehicle system. a new course with a content where we go on the one hand into the system powertrain, to have within a vehicle the powertrain. So it's not chassis, it's not body, it's really the part which is providing the energy to move the car. Then we have the electric drive system design. We have some aspects of functional safety. Functional safety, many will know as the ISO 26262, which is taking care of safety for the passengers and also the people around. And then we have system energy management. So these are the parts of this course. Here I have an introduction view. So you have exactly these 4 parts which I just stated. And we can go into some of the content to have a sneak peek into it. You could have gone via the buttons too. Yeah, I'm so used to left side, but its navigation would have been there, possible
After
there too.
having learned about the important elements of an electric...
So here I would say the definition and elements we skip, and we have a look at the architecture, powertrain architecture transition. Why transition? Many projects are still changing from combustion engine to the electric vehicle. And so many people who need also the support in understanding what is changing, what do I know today and what do I have to take care of tomorrow. And this is a short explanation which is giving this view.
After having learned about the important elements of an electric vehicle in the last slide, we now want to have a look at the system architecture itself. Under the term system architecture, we understand a conceptual model which consists of system components and the subsystems, and it defines, amongst other things, the structure and behavior of a system. Consequently, the architecture looks quite different depending on the different components and systems inside the respective architectures. For a combustion car, we see the powertrain architecture here. It includes, for instance, a fuel tank, an exhaust system, an air system and a cooling system. We want to consider how this architecture changes on its way from a combustion car to an electric vehicle. There are 2 different ways to do this. Either you go directly from a combustion car to an electric car, or you go from a combustion car to a hybrid before going to an electric vehicle. Click on the buttons to select a topic.
Okay, so here we see the combustion engine, and now we'll see what's changing to have an EV.
The first option is to go directly from a combustion car to an electric car. This requires the introduction of new high voltage systems and new thermal systems.
Okay, here the high voltage system means the battery, the electric drive, and here you see the cooling system. And now we look at the second one.
The second option is to go from a combustion car to a hybrid before going to an electric vehicle. With this approach, the first stage is to add the electric parts inside a combustion vehicle, and afterwards the combustion part is reduced to 0. This leads us to an electric vehicle.
Okay, and then we see we have lots of other parts which we can explain. I will just now switch to some aspects of functional safety. And here you have, for hybrid electric vehicle or electric vehicle, the safety goals concerning torque, thermal events, and high voltage. And I'll start this now.
In order to gain an impression of what the typical safety goals are in an electric vehicle, we will consider 3 examples. Click on the symbols to select a topic. First, there are torque-related safety goals. For example, it shall be avoided to drive off against a desired direction. The electric machine can be controlled via software in both rotating directions, and so only one mistake can lead to a wrong direction driving. Hence, this needs to be avoided in typical use cases. This safety goal is typically rated with an OSL B, and we have to react within 100 milliseconds. An additional example is the torque applying without a driver intention. This could happen during charging, for example, when no driver is sitting in the car, but the system is still awake and working, means you only do small functions, so the vehicle could still drive off. And this of course needs to be avoided. The most critical torque-related part is the unintended braking. That means in this case, the vehicle can go into an unstable situation, and the driver can be injured by a mistake in the system. This safety function is related to an OSL D, therefore the most potential risk. There are further safety goal examples. One of them are the thermal events. This could be that a fire could occur due to an overcurrent or short circuit, and that of course shall be avoided. An additional thermal event could be a short circuit of the high voltage battery, which also has to be avoided, for example by a high voltage battery fuse. In case of a vehicle incident, a high voltage contact to any humans, for instance the emergency paramedics, has to be avoided. A possible measure is the active discharge function in all high voltage components, in order to bring the voltage level to a safe level.
So these were like the safety goals, and of course there's explanation behind how to implement these safety goals. I would say this is for today what I wanted to show you, to have an impression on the new content which we are providing. We will have another Embedded Academy What's New quite soon again, because I don't know, we've been piling up releases. There will be 2 other topics released within the next weeks. So we'll see if we do before or after Easter. And I want to thank you for taking your time and being constantly interested in our new releases. We will publish these What's New for a longer period of time on YouTube. And as we said before, we will also have a newsletter on a regular basis, and are grateful and happy if you sign in. Thank you and have a nice remaining day.